Welcome to the Deep Dive. Today we're taking a look into something, well, pretty cutting edge. Rain-powered solar panels.
It sounds almost like science fiction, doesn't it?
It really does. Our mission for you today is simple. We'll pull out the key insights from our sources, giving you a shortcut to understanding this innovative tech. It's still experimental, mind you.
And we're focusing on a really interesting case study in Dover, Delaware.
Exactly. So when you hear rain-powered solar, you might just picture, a panel getting wet. Simple enough. But you're telling me there's actually something quite different going on.
Yeah, absolutely. What's really fascinating here is it's not just about the panel being wet. We're talking about a true hybrid energy system.
Okay, hybrid. How so?
So these aren't just your standard PV solar panels. They have these ultra-thin layers of graphene built onto them.
Graphene, right, that super material we hear about.
That's the one. And this graphene layer, it actually reacts with the rainwater itself. It's a bit like a tiny chemical reaction, a Lewis acid case thing between ions in the rain and the graphene.
So it's creating electricity from the rain hitting it, not just collecting sun when it's not raining.
Precisely. It generates a voltage during precipitation. The rain isn't just an inconvenience, it becomes another power source.
Okay, let's talk numbers then. How much does this really add? Is it, worth it in terms of efficiency?
Well, typical solar panels, good ones, might hit around 22.5% efficiency converting sunlight.
Uh-huh.
The graphene layer, based on current tech, adds about another 6.5% efficiency, but this time converting the energy from falling rain.
6.5%. Okay, that's, well, it's not doubling the output, but it's definitely something, especially on cloudy days, right?
Exactly. It shifts the thinking. Bad weather isn't just zero production time, it's supplemental production time. It means you're potentially generating power more consistently.
But you'd still need batteries, I assume. For nighttime or just really heavy cloud cover without rain?
Oh, absolutely. Energy storage, like lithium batteries, is still crucial. This makes the grid more stable, but it doesn't eliminate the need for storage to smooth things out.
Got it. So we have this cool tech, but let's pivot to the location. Why Dover, Delaware? What makes it such an interesting place to look at for this?
Dover's climate is, well, it's almost tailor-made to test this, both the potential and the challenges.
How is
It
that?
gets a decent amount of rain, around 45 inches annually, and importantly, about 12% of that falls during hurricane season. Plus, you're looking at over 120 rainy days a year, lots of opportunities for the rain power aspect.
Okay, but you mentioned hurricane season. That sounds like a major stress test.
It absolutely is. Dover usually sees one or two tropical storms each year, and then every 5 to 7 years on average, they can get hit by a major hurricane Category 3 or stronger.
Category 3. That's serious wind. We're talking upwards of what, 110, 130 miles per hour?
Even higher. Category 3 starts at 111 mile per hour, but they can face winds well over 150 mile per hour and stronger storms. So resilience is not just nice to have, it's essential.
Right. So what does that mean for actually using these panels there? How do you make them tough enough?
Well, existing large solar farms like the Dover Sun Park already use things like tracker systems. These follow the sun, boosting efficiency, but they're also built pretty tough. Some can handle winds up to maybe 75 mile per hour or 117 kilometer per hour.
Okay, but that's still way below major hurricane force.
Exactly. So for these new hybrid panels, you'd absolutely need specialized hurricane-rated mounting structures. That's critical to stop them from, well, becoming debris themselves and to ensure they last.
Let's talk about integrating this into something like that Dover Sun Mark you mentioned. It's a big facility already, right?
Oh yeah, it's substantial, 10 megawatts across about 103 acres. They use sun power panels already pretty good at 19.5% efficiency, and those trackers boost the yield by maybe 25% compared to fixed ones.
So if they were to upgrade to this hybrid tech, what would that look like?
You'd be adding the graphene layers, so the overall efficiency climbs, you get the, say, 22.5% from improved solar tech plus that 6.5% potential from rain.
Is it expensive to add this layer?
Well, the prototype costs suggest maybe an extra $3,200 for a typical 11 kilowatt residential size system. But there are potential upsides beyond just the extra rain power.
Like what?
Better storm resilience, potentially. The materials might be more corrosion resistant. And some research suggests graphene can be sort of self-cleaning, which could actually reduce maintenance.
Interesting. Okay, let's bring it down to the homeowner level. What does the economic picture look like for you, the listener, thinking about residential solar? Is this hybrid tech worth the extra cost?
That's really the million-dollar question, isn't it? Or maybe the $3,200 question in this case.
Ah, right.
So a standard 11-kilowatt system after tax credits might cost around $20,500. It could save you anywhere from, say, $30,000 to over $100,000 over 25 years. Payback is usually around 7 years or so.
And the hybrid version.
The estimate puts it around $23,750, so roughly a 15% premium up front, that extra 6.5% rain generation. Over 25 years, that might add up to about $4,500 in extra value or savings.
So $3,200 extra cost for about $4,500 extra gain over 25 years. It's positive, but maybe not a slam dunk yet, economically speaking.
It's a bit marginal right now for pure economics, yes. The payback period gets longer. The real argument might be more about future-proofing and resilience, especially in wetter or stormier climates. But there are still hurdles.
Oh, yes.
We just don't have a lot of long-term data on how well these graphene layers hold up under repeated stress, especially hurricane conditions. And that higher initial cost is definitely a barrier compared to standard solar's faster payback.
Okay, so let me try and wrap this up for you. This rain-powered solar idea, it's definitely exciting, very promising, but still kind of in the experimental phase, particularly for rough weather zones.
Right.
Dover's climate is a great place to potentially benefit from the rain aspect, but that same climate, with the hurricanes, demands much tougher, more expensive designs.
Makes sense.
And for homeowners, the economics are still developing. That extra energy boost from rain might not quite cover the higher installation costs just yet, making the payback take longer than standard solar.
Yeah, that sums it up pretty well. But it does lead to a bigger thought, doesn't it?
Go on.
Well, this raises an important question. As we see climate patterns shifting, maybe getting wetter or stormier in some areas, how might the actual value, the real proposition of technologies like this change, even with the challenges they face today?